last example of constraint optimization is a business application. So here in this case, we are to maximize the output, which is this function. We call it a Cope-Douglas function. Okay. And on top of that, we were told that the price of capital is 6. So P of K equals to 6. And the price of labor is 2. Okay. The price of labor is 2. Price of capital is 6. And also we know that the budget is 960. Okay. So here you were asked to solve out the amount of labor and capital that maximize the output, and also estimate the benefit of having an additional dollar in the budget, which is the shadow price, namely the Lagrangian multiplier, or lambda. Okay, so here, let's get to this. So in this case, first, we are to solve for K and L, which are your choice variables. And your target is Q, which is 1.5 by K to the power of 0.6 multiplied by L to the power of 0.4. Okay. And then we have the constraint, which is the budget. So left-hand side and right-hand side. Okay. So right-hand side is the budget itself, 960. Okay. Let's just move this one step to the right. So it's smaller equal to the total budget, and left-hand side is the total expenditure. That is 6 multiplied by K, which is the total expenditure on recruiting capital, plus 2 multiply L, which is the total expenditure on recruiting labor. Okay, so now we have all this, and let's experiment using solver to directly realize the maximization goal. So it is maximize quantity by choosing capital and labor, add the constraint that the left-hand side is smaller equal to the right-hand side, 960. And here it's okay to keep this box checked. Why is that? Because both capital and labor should be non-negative. So we want to make the free to change, namely unconstrained variables, that's your K and L, non-negative. You can't recruit negative labor or capital, right? So here we hit solve. And you can see we don't have a result. Why is that? It is for this special case where we have a very complicated functional form of the objective function. Possibly solver will get confused. So you can randomly input certain number. You don't even have the guess. And then you let solver to solve. And here we have the correct answer, which is 96 for K and 192 for L. So you just need to input, in this case, need to input some initial numbers in K and L to activate the optimization calculation of solver. Okay. Due to the complicated functional form of the objective function. So solver is not that good with those kind of power form, complicated power form. So you need to have this kind of initial numbers input in there. Okay. And it is also asked to report to estimate the benefit of having an additional dollar in the budget, which is the value of Lagrangian multiplier or the shadow price or lambda. Okay. So what we do is after hitting solver, we let it report sensitivity reports. Okay, so in this case, we have sensitivity report 2. So usually what Excel does is to put this ahead of the worksheet. What I like to do is to put this after the worksheet. And what I would suggest you to do also is to rename it. Okay, all right. So in this case, we have the final values, and the Lagrangian multiplier's value is also estimated here as the reference, which tells you how much the output will change after switching, after loosening the budget constraint by $1. So that is the result here.